While most people are barely paying attention to space right now, something genuinely interesting is unfolding above us. New images just dropped from Hawaii. These aren't what we were expecting. The antitail structure is completely different from earlier observations. It's sharper, more defined, and it's raising serious questions about what we're actually looking at. When we zoom in on the nuclear structure with 10 times magnification, something really stands out. The jet stays incredibly thin, even at extreme detail. If this was standard dust scattering from sublimation, the particles would have dispersed by now. Pressure gradients alone would have spread them out across a wider area. But that's not happening. The jet maintains that razor-thin profile. That level of coherence, that kind of organization, it doesn't fit the fragmentation models. It doesn't fit the random outgassing we typically see. Here's the latest frame from Michael Uger captured on November 28th. Take a look at that antitail. It's razor-thin, no diffusion, no scatter, none of the usual widening you'd expect from dust drifting away in different directions. This thing holds its shape straight, tight, geometrically clean. Whatever is driving this, the material isn't just floating outward. It's being directed along a very specific path. Now, take a look at this. When we isolate the inner structure using the Hawaii data, the jet doesn't behave like a normal dust plume at all. It stays unbelievably narrow even as it stretches out across the frame. If this was standard outgassing, solar pressure would spread those particles into a wider fan shape. But that isn't happening here. The jet holds a straight, consistent profile, almost like it's being guided instead of scattered. That kind of coherence is the exact opposite of what we see during fragmentation. It's the signature of a stable, controlled emission coming from a very specific point on the nucleus. Now, take a look at the latest Hawaii sequence from Calopa stars. These frames were processed into a refined 10-time zoom, and the structure that comes out of it is nothing like the earlier images from this month. On the left, you can see how dense the inner coma actually is. No breakup signatures, no secondary peaks, just a clean, concentrated center. Move to the right and the directed emission becomes impossible to ignore. The antitail stretches out in a straight focus line, thin, coherent, and far more stable than what dust physics alone should produce. And here's the key detail. These images were pulled from modest equipment. A CS50, short integration times, and still the geometry stays sharp. If the source was chaotic, the structure wouldn't survive this kind of zoom. But it does. That's a part nobody can explain yet. Here's the thing. When you line up the Hawaii frames across several nights, something jumps out immediately. The structure isn't drifting. It isn't wobbling, and it sure isn't acting like a debris cloud. Start with November 22nd. This is a 23-minute stack. Cloudy edges, faint background drift. But even here, the core stays perfectly vertical. No distortions, no splitting. Move to November 23rd, longer integration, clearer sky, and that central column becomes even more defined. The glow thickens around it, but the axis stays razor straight. By November 25th, after 31 minutes of exposure, the pattern becomes obvious. The tail shows faint micro-textures, little ripples in the outflow, but the center still locked in place. Then, November 26th, 36 minutes, same result. The brightness increases, the halo expands, but the core doesn't deform, not even slightly. And when you put them together, like in this collage posted by Calopa stars, the progression becomes almost impossible to ignore. Different nights, different levels of sky transparency, exact same core geometry. Whatever this object is doing, it's doing it consistently. And that consistency is the part no one really knows how to explain yet. And here's something important. These aren't optical images. These are ALMA radio maps of the actual molecules coming off 3I Atlas, methanol, and HCN. What's striking is how compact the emission is. Every single map shows the gas concentrated in one tight region. No secondary peaks, no scattered sources, nothing that would hint at fragmentation. Even the elongation matches the same direction we're seeing in the optical jet. So, not only does the light structure look focused, the chemistry confirms it. NASA's high-resolution imagery is coming soon. That's when we get the real picture. Hubble-class resolution will show us the jet's internal structure at a level we've never had before. When that data drops, We'll know whether this directed geometry is temporary or something fundamentally real. Stay curious, stay grounded, and I'll bring you the next update when more frames show up.